Most of us think of buildings as just, well, static shells of concrete and glass. But what if they had a secret life? What if they were intelligent, living ecosystems, constantly adapting and maybe even thinking? That's exactly what we're going to get into today. And I mean really predicted. We're not talking about just guessing the weather. No, no. Imagine a building that knows a pipe is about to burst days before it happens, or one that adjusts the airflow in a room before you even realize you're feeling a little stuffy. This isn't science fiction anymore. It's the next evolution in how we live and work in our spaces. For decades, managing a building has been a totally reactive game. You've got these separate, siloed systems for heating, lighting, security, and none of them talk to each other. It forces us to rely on manual checks, just to find problems after they've started. But we're leaving that fragmented past behind for a new reality. A single, unified brain for the building. A system that thinks ahead to stop issues before they even begin. So, what's holding us back? Well, the core problem is with our current building management systems, or BMS. These are supposed to be the digital nervous systems of our buildings, but frankly, they just aren't keeping up. They were designed for a much simpler time, and in today's complex, data-rich world, they're really starting to show their age. Just think about the common frustrations. You've got different brands of equipment that can't communicate, sky-high costs to get anything installed, and user interfaces that look like they're straight out of the 90s. Research shows these are the exact barriers that have kept most buildings from being truly smart. They promise a lot, but in reality, they're often clumsy, expensive, and a real headache to use. So how do we fix this whole mess? Well, the solution lies in combining three incredibly powerful technologies. Think of them as the dream team for modern building management. First up, we have the digital twin. This is basically a perfect living virtual copy of the entire building. Every single sensor, every pipe, every room, it's all mapped out in a dynamic model that gets updated with real-time data. It's like the building's digital soul. Next up, artificial intelligence. So, if the digital twin is the soul, then AI is the brain. It tirelessly sifts through this massive stream of data from that virtual model, hunting for patterns, spotting tiny little anomalies a human would never catch, and predicting what's probably going to happen next. And finally, the piece that ensures trust and security: blockchain. Think of it as the building's unchangeable, super transparent public record. Every maintenance request, every energy reading, every payment, it's all recorded in a digital ledger that literally can't be altered or deleted. This creates a foundation of total accountability. So here's how this dream team works together in a beautifully simple flow. The digital twin gathers all the data, the AI makes sense of it, and the blockchain records everything securely. This constant cycle of data, analysis, and secure logging is the engine that lets a building shift from being reactive to being truly proactive. Okay, so having cool technology is one thing, but making it actually useful? That's a completely different challenge. So how did researchers figure out what this system really needed to do? They went straight to the source. Over 2 years, researchers did these in-depth interviews with 27 industry experts from all over the world, and they basically asked them one simple thing. What are your biggest pain points? What would actually make your job easier? See, this was never about building tech for tech's sake. It was about solving real human problems. And what's so fascinating is seeing how directly that feedback shaped the final product. The experts said security and data integrity are our #1 concern. So the system delivered with blockchain-backed security. They said these systems are way too complicated. So the system delivered a visual, intuitive dashboard. They wanted to predict problems, and bam, the system delivered predictive analytics. It's a perfect example of a direct line from human need to a technical solution. All of this research led to more than just a theory. It actually led to the creation of a functional prototype, a real, working model of this futuristic system. And to test it, the researchers didn't just use simulations. They used something much better: 3 years of actual, historical data from an administrative building in Sweden. This meant they could see exactly how the system would have performed in the real world, against real challenges and real energy demands. So what does this actually look like for a user? Well, this snapshot from the prototype's dashboard says it all. Instantly, a facility manager can see the building's energy vitals: cooling, heating, electricity. No more digging through spreadsheets. The data is right there, visual, and immediately understandable. And this timeline, this brilliantly illustrates the proactive power we've been talking about. On day 1, the AI detects a tiny anomaly in the HVAC system. It's not broken yet, but something's a little off.
By day 2, a smart contract has already sent a maintenance request to the manager. A provider accepts the job, and by day 5, the work is done, the provider is paid automatically, and the entire event is logged on the blockchain. The problem is solved before it ever became a real problem.
This quote from the research really just nails it. The magic is in the automation. By using these smart contracts, you remove the bottlenecks, the paperwork, and all the manual follow-ups that slow everything down. It's all about creating a frictionless, super efficient workflow. But the impact goes way beyond just maintenance and saving money. The system connects directly to broader sustainability goals. A green metrics module, for example, visualizes the building's carbon footprint, breaking down exactly where emissions are coming from. This gives managers the power to make targeted, data-driven changes to reduce their environmental impact. So, stepping back, what's the bigger picture here? Why does integrating all this technology into our buildings truly matter?
The impact really boils down to 3 key pillars. First, there's the environmental one, buildings that use less energy and have a smaller carbon footprint. Then you've got the economic pillar, massive savings from cutting operational costs and making expensive equipment last longer. And finally, the social pillar, creating buildings that are simply better for people, more comfortable, healthier, and more productive places to live and work. For the first time in history, our buildings have a voice. Through massive amounts of data, they're telling us exactly what they need and how they can be better. The technology is here. The real question now is about us. Are we ready to listen?